yeah, I hope that it's not going to be too complex. I've tried to, we're going to cover some ground this morning, but I hope it's not going to be an odyssey. First of all, yeah, my name is Michael Wolf. I'm an interaction designer based in Cape Town, and I'm working on the intersection between human and technology, which is basically which we call the interface. Before I start the talk, I wanted to thank so much to Catherine for Creative Morning Cape Town and to organize that. And also I would like to thank Tina Roth-Eisenberg for this fantastic format, this global format of Creative Mornings. And it's so amazing to be able to speak simultaneously with, how many, I'm not sure, but probably close to 100 other events. Also like to thank John Maeda for the great topic. And Catherine hasn't touched on it, but just very briefly, in a nutshell, STEM to STEAM is a fantastic initiative by the Rhode Island School of Design, which basically the STEM principles stand for science, technology, engineering, and maths, which are to be, pushed, which have been pushed in the last decade to as a key driver for innovation in education. And John Maeda and Rhode Island School of Design have, added another very important feature, which is the A, which makes STEM to STEAM, and the A stands for arts. Now, I'm not an artist, and I call myself a designer, and I have a clear distinction between arts and design, but I think we get the point. We need creative influence to, work with designers or work with scientists and technologists to create that human factor which we're missing so much in technology of these days. So let's watch some sci-fi.
Come this way.
These are the talking men?
Yeah.
They speak. Of what?
Things nobody understands.
They told me.
The war between the East and West, which is now in its 326th year, has at last come to an end. There is nothing left to fight with, and few of us left to fight. The atmosphere has become so polluted with deadly germs that it can no longer be breathed. There is no place on this planet that is immune. The last surviving factory for the manufacture of oxygen has been destroyed. Stockpiles are rapidly diminishing, and when they are gone, we must starve.
Now, isn't that magic? Isn't that amazing how a 1960 sci-fi movie based on a scenario based on a novel by Orson Welles can suggest such a wonderful interface that makes us interact with technology, makes us interact with digital technology. You could see a little bit in the face of the faces of the actors that they actually almost think that it is magic. But it's not. It's actually happening. And I'm going to show you another example where the same technology or similar technology is actually being translated in an actual project. This is also already 10 years old. It's a group at MIT Media Lab called the Tangible Media Lab, led by Hiroshi Ishii.
Hi. Well, I can't talk for long because I'm in the middle of trying to conjure the water spirits. Well. Hello there. What are you doing? I'm meditating. I'm calling water spirits to help us.
Brilliant. Your answer to everything.
It's another beautiful day in the park.
Hello.
What you're seeing here is actually an experimental interface by a group of media artists and interaction designers who have the privilege to experiment with new ways of interaction with technology. I'm a big fan of Hiroshi Ishii, and this is a project that's already 10 years old, and as I said earlier, it's actually been realized in technology. So makes us think. You know, the interface, what the interface should support as an intersection between technology and the human factor is to make machines and technology more humane, to make it more intertwined with our behaviors, and not to force the machine upon the human. This image shows quite nicely our relationship to technology. It's been a battle for a long time. It is also an intersection, it's also a handshake. It is that middle area where the hands touch, which is interesting to us interaction designers. It is here where we have to create this connection that will allow both sides to get their share, and we have to ask the question, which side is more adaptive and compensates for the flaws of the other, man or machine? But let's talk about magic. Who in the audience believes in magic? Wow. Oh, it's quite a yeah, it's quite a surprise. Well, I, for my part, I was quite amazed about this graphic in the beginning, and you know, arts and technology and the intersection becomes magic. Obviously, there's quite a wide interpretation of what is perceived as being magic, and I thought around it, and maybe it's a little bit of a long shot, but I have started to think about, you know, the 1001 years, the magic that the magical stories that happened in sort of the 9th and 10th century in the Middle East. And interestingly enough, it was a time of great technological development in the same region. We had 3 polymaths, which are essentially people who are not just specified on one, specialized in one field, but who are scientists, mathematicians, engineers, and artists and designers at the same time. The 3 Banu Musa brothers. They created this book of ingenious devices, which comprises of is a compilation of hundreds of contraptions and mechanical innovations that were at the height of the technology at the time. But they also referred to these devices that they created as trick devices. They were made to astound audiences. They were playful items that they used to experiment, and they would bounce off audiences to astound them. And also, and here maybe that's a question, trick them. The question would be, does technology really have to trick people? Do we have to believe in magic to make technology work? 2 examples. These are devices that were drawn up probably already in some format by their Greek ancestors, but also now translated and further developed by the Banu Musa brothers. We have the first types of robots. We have the perpetual flute on the left, which is a device when you fill in water at the top. The lever at the top alternates, dispersing the water first to the one side, then to the other side, while creating a whistle sound of 3 different tones and a little melody. What you can't see really here, well, you can see it, is actually a section view. Those guys at the time in the 9th century, they were very well aware of creating a section view to see the internal mechanism. But this internal mechanism was not visible to the audience. So what they essentially did at the time, they created what we now call a black box. It is a mechanism which was perceived to be too complex to be understood by the audience, maybe, or maybe just to kept away from them to make them, you know, believe in the magic. These days, you know, the term black box actually refers to a much later period in the 1930s when the forerunners of the modern day computer were designed, where engineers and technologists created such complex mechanisms that could not be understood by just looking at them, nor could they manipulate it by directly interacting with them. So they call it a black box. The only thing that the only way people would interact with that black box was through an input and an output. And this is exactly the domain where we interaction designers work in. We're creating interfaces for input and output into these complex technologies that we house in black boxes. For a long time in the history of technology, and there were items that were complex to a certain level and also simple at the same time, where you could actually see when interacting with them how you were manipulating with them, and that would also, by a simple look at them, exactly represent what they are and what their function is. Such as this wonderful example of an abacus, which was designed about 100 AD. In the industrial age, however, things started to become very complex. There was these big complex machines which suddenly arose, and which nobody would really understand anymore, like a layman, in layman's terms. This is a wonderful example where we actually have a Bell's switchboard. And I don't really know why this lady smiles so much, because I would be terrified if I had to operate this monster. So what we're seeing here is not really a design interface as such. It's actually quite a natural interface. It's actually the way of, I don't know if you guys all know how this switchboard works, but you're actually you're operating the machine, which is inherently, or which is connected to the inherent function and principle of the machine. You're actually literally connecting the wires by unplugging, plugging them back in, and connecting people. But obviously that only worked to a certain degree. Now things got too complex and had to be created. The next bombshell that dropped was the computer. This is the Xerox Alto, one of the first personal computers that was rolled out to a bigger audience. The first time actually a keyboard and a mouse and a screen in conjunction were proposed as an interface, of which the mouse here, the early prototype by Doug Engelbart, designed in 1963. So you must imagine, this design is, next year, it's going to have its 50th anniversary. And just look at it. I mean, it looks crude, it looks rough, it looks like a prototype, but we're still using it. And it's pretty much the same, exactly the same, like the mouse we're using today. On the other hand, there was the screen interfaces that had to, change, because the first people to operate computers, they had to deal with machine language, which was like a command line approach, where you literally had to tell the computer now, access this file, move to that point, not even thinking about spherically or spatially. So up came Windows, which was not called Windows at the time, but which was already bringing across the Windows metaphor of a graphical user interface. And here's an interesting thing. We're trying to make now these complex systems, bring them together into a very simple graphical user interface, or very simple interfaces. And we're using these metaphors and analogies from the real world. While we call it Windows and desktop and all of these things, obviously people we're dealing with something, an entirely new technology, and it's understandable that designers choose to pick these metaphors and analogies from the real world. My favorite example is the button. The button has been around for a long time. It's been deployed in electronic gadgets. But really, why are we still using buttons that look like physical buttons in a graphical user interface? It's a bit absurd, isn't it? But on the other hand, it's also, again, understandable, because this is what people know. This is what people have learned over centuries, not over centuries, sorry, over generations. A button is, you push it and something happens. Again, this also symbolizes our relationship to technology. We like to make things happen by the push of the button, and that's what we expect from technology in some form. We we can obviously ask the question if that's our right approach to technology, if we really still should think about pushing buttons, or more about processes and how we can influence processes, rather than execute orders. So a big problem with innovating these interfaces and coming up with new things is the so-called habitus, which is a certain behavior that becomes part of society's structure, even when the original purpose of that behavior or belief can no longer be recalled. So we're still using buttons that look like buttons, we're still using menus and things like that. We got so used to these things that we don't want to give them up, actually. So that's why a lot of designers struggle to actually be innovative and come up with new ideas, because all of the new ideas, they will fail terribly in their usability tests. I mean, I'm talking a bit black and white. Obviously, there's gray areas in between where a certain, innovation is possible. But we find many usability experts and designers who actually advise, guys, use a button, put it in that position, and that's how it's going to work. So how do we get out of the cycle? But first, before we address that question, I want to ask, why would we actually change a running system? Isn't it working great? Isn't it working fantastic, the way our interfaces work now? The way we deal with computers? And there's two things I want to say about that. Firstly, the interfaces that we use, for example, mouse, keyboard, and screen, are not addressing at all the capacity of humans, the behavior, and the tools that we have as humans. Our perception has far more greater possibilities than just like the little sensomotoric skills and the visual apparatus that we're using when interacting with computers. The other thing is that idea of the universality, the universal machine, universal interfaces. That's why we like buttons so much, because you can apply them to anything you like. A button can have a different label and it can be something completely else. It can be to call your wife, or it can be to fire a rocket. So these days, it's just simply not acceptable that you're using the same tools and the same interface for, let's say, a 3D CAD program and a text editor. Let's see what Scotty has to say about this when he came back from the Star Trek travels to Earth.
Please.
Computer? Computer? Hello, computer.
Just use the keyboard.
Keyboard. Oh, great.
I would like to give you a couple of examples what we do at our company, Formula D Interactive, to address those new areas of interface that we think will be the future. Our company has the privilege to work in a field which is a niche that allows a little bit more experimentation than, say, for instance, people who are working on a product that will be rolled out in the millions. We work in the field of interactive exhibits and installations in spaces, which allows us, like, each project is almost like a new prototype, which allows a little bit more to push that side or push the other side and experiment a bit more. So, which is a nice thing, we enjoy it. The first area we're looking at is the tangibility of interfaces. Interfaces that can be manipulated with your hands, because tactile senses and us grabbing things, feeling things, is very much a skill that is not used at the moment. Here's a very old example of a prototype I designed, which is a musical interface to actually sequence sounds, which allows children to learn about composing sounds, gives them tools to work with digital sound clips and samples. The tool consists of a base station, various mushroom-shaped items that each reference a specific sound. Once you plug them into the base station, which is wirelessly connected to a computer, the sounds will play. You have these secondary objects, which are the leaf shade objects, which you plug into the mushrooms and which then modify the sound. At the bottom left you see the shuffle, which is a wireless microphone. When you plug the microphone mushroom into the shuffle, then it starts recording whatever you're holding the thing towards. Then you can replay that sound on the base station. This was actually built in at Fraunhofer Institute of Technology as a prototype, and here's just a quick clip with some kids. Mustn't forget, this is a computer that is running this. So you just applied an effect to the sound which makes it. The other area, and I'm seeing I'm running a bit over time here, the other area I wanted to quickly touch on is gestures. You know, we're doing so much with our hands, and we're pointing, we're waving, etc., and it's not used at all in the interfaces. Now we see a lot happening in that field. So we're also exploring, you know, ways to interact with pointing at the screen. Here's an interface that allows you just the one pointing gesture to navigate. But there are a whole lot of questions now that come up. You know, how do you navigate without a click, and how do you what is the right ergonomics for a pointing interface? So you see, we came up with this graphical, circular interface, which works quite well because it kind of follows the hand motion and your ergonomics. You just simply can't apply the same rules like you would on another touchscreen or another interface. Also, the body in space is completely underutilized in interfaces at the moment. So we started playing around a lot with the new Kinect controller, which has opened up a whole world of interaction, and you know, any interaction designer should actually get into this because it's amazing what can be done. Here we created like a small installation for the Cape Leopard Trust, which is at a wine farm in Franschhoek. So you can see the camera tracks the person in three-dimensional space, and now you can walk up to this big screen and navigate certain hotspots and call up content by navigating your body. Obviously, this is just beginning stages. I mean, there's much more that can be done with that. But again, we have to first get users accustomed to the way of interacting. We find quite a lot of people who stand in front of a screen and they now think they need to stand still, although, you know, we think the interface is quite intuitive, but it's actually not. When people see a screen, they want to touch or they want to drag, but they don't think they can move in front of it and do something. Ambience. Our receptive system works not only in the focus domain, it works, like right now, you know, I perceive many things at the same time, although I'm focused on this presentation. You know, I know there's light airstream I realize there's a light airstream from the aircon, which makes me feel rest assured that I'm not going to suffocate, and it's, you know, there's many things that that we compute at the same time, although we're not focused on a specific task. So ambient interfaces, there's a lot of opportunity here to create interfaces that compute digital information, that let us perceive enhanced environments through technology. We had a very nice project with Ogilvy for a club in Cape Town, the Galaxy nightclub, which was an 8-meter projected wall which would project onto glass, and it actually is in the middle. There's a door section, and it's called a VIP area, but anybody can enter. And we installed 2 sensors on the door that would then enable us to track if people enter the room or leave the room. So now on this display, we showed like a virtual underwater world with these strange creatures floating around. And the moment somebody would enter the space, we would create a creature that would be added to the tank. And the moment somebody would leave the space, we would kill a computer language again. We would destroy it, and it would then disappear. So users or people in the space would get this ambience and this idea without having to focus on it, how many people would be in the room and how busy it was. Which is for a nightclub not always the best thing to do, because if nobody is, if there are no fish on the tank. But I suppose it depends what kind of fish is in the tank. Sorry, it's a very bad video. We don't have a lot of video of this, unfortunately. But this is how it looked. So here's the door. You could also send SMSs to the screen with a certain number. We connected the GSM receiver. So if you would, for example, SMS mermaid, a mermaid would swim through the tank. One thing that is at the heart, and that's like my finishing point, at the heart of what we're doing at Formula D and what we do in the context, especially being in South Africa, is designing interfaces that will allow an inclusiveness of technology, that would allow greater access to technology, specifically also since we're focusing on education. We have the situation that we all, probably all of us in this room, have a thorough history with computers and basically grew up with computers around us, and at least some access to computers. Unfortunately, this is not the case for the majority of the world. Specifically in Africa, the majority of people probably have never interacted with a computer at all. So now, how do we tie them into the knowledge economy, the technologically boosted knowledge economy? How can we develop those? And we're thinking around interfaces that would be, avoid traditional interfaces to traditional ways of interaction in order to give people better access, including kids and previously disadvantaged communities. For instance, we designed this virtual chemistry lab desk, which is based on the Reactivision protocol, and allows us to use these physical objects to navigate and control a simulation software to teach people about chemistry. The big advantage of this is, obviously, you don't have to understand, how a keyboard works or how a mouse works. You can just grab, like, very close to the actual work in a chemistry setup in a chemistry lab. You can get the different ingredients, place them onto the table. They would appear on the screen and interact together. You would have, we have different cards. We have the elements, the chemical elements, and we have tool objects like a thermometer or a periodic table which shows you which is the current formula, or a microscope which shows you what's happening on a molecular level. We also have a tutor card, and you can see that the simulation of the experiments is pretty realistic. So this is an option to fairly low cost produce a chemistry lab for schools that don't have access to the real thing. Just wanted to quickly summarize. In conclusion, I believe that technology cannot succeed without the input of designers. Designers study users, their contexts and behaviors in order to conceptualize technology interfaces that bring out the best of technology and address the needs of people. But we also need artists, novelists, futurists, sociologists, and everybody to work together, in multidisciplinary teams to forecast sustainable futures with humane technology. Thanks very much.